Welcome to Study Loop.
Okay, so we have a thin uniform rod was bent into a square. Okay, and this square has a length A, like the first drawing shows. Okay, if the total mass of the rod was m, okay, we want to find the moment of inertia about an axis through the center and perpendicular to the plane of the square. And we have to do this using the parallel axis theorem. Okay, so this is like the first is like the above view. This is more like a second view. You see I have four moments of inertia of a center of mass, because I can think of the square as four rods, okay, four separate rods. And I have the moment of inertia P that is in the center of the square, okay, and it's the one I want to find. Now, it's, as I said, this is easier if I think of this like this as a single rod, okay, and then I add up the contribution of all the rods that at the end it's the same because they are equal, okay? So I have a length A, okay, of each of the sides. So you can see that the distance from the center of the square to one of the rods is A. And since the total mass is M, then the mass of each of the sides is M divided by 4. Okay, so if I think this as a single rod, I have something like this. This is the distance, okay, A over 2. Okay, I have a mass M over 4. Okay, and I want to find the moment of inertia through P. Okay, so first notice that we know that the moment of inertia through a axis in the center of a rod, okay, it's what I'm going to call I of the center of mass, is 1/12 of the mass times the length square. Okay, I know that the mass is m over 4, and I know that the length is A. Okay, so I'm just going to rearrange this in terms of the variables, and this is 1/12 of m over 4 times A squared. Okay, so this is the first part. And now I know that the parallel axis theorem, okay, says that the moment of inertia through a point P, okay, equals the moment of inertia at the center of mass plus the mass times the distance from this to P squared. Okay, so I know that this distance, okay, remember it's the distance from this blue axis to the red one, is A divided by 2. Okay, I know the mass, okay, and I already know this I through the center of mass. Okay, so it's as easy as finding that IP is equal, okay, to 1/12 of M4 times A squared plus M4. Okay, this is what I had before, and this is, I'm going to substitute it. This M over 4 times the distance, that is A divided by 2 squared. And when you rearrange, you find that this is M A squared times 12. Okay, but this is just for one rod. Okay, I have 4 rods, okay, because I have 4 sides. So for the total moment of inertia, and I'm going to put this in green, okay, it's going to be 4 times the value for one rod. So 4 times MA squared divided by 12, and this is then that the moment of inertia is 1/3 of the mass, this side square. Okay.